Hello everybody. Hello everybody. The fourth lecture, analysis of algorithms. Algorithms course lectures for second level students, Bورسعيد University, Faculty of Science, Department of Mathematics and Computer Science. A symbiotic notation. The notation we use to describe the symbiotic running time of an algorithm are defined in terms of functions whose domains are the set of natural numbers. Natural numbers equal the set of 0, 1, 2, so and so. On it O notation for a given function g of n denoted by O g of n function. The set of functions O g of n defined by f of n, there exists positive constant c and n node such that f of n less than or equals cg of n and greater than or equals 0 for all n greater than or equals n node. We use O notation to give a symbiotic upper bound of function to within a constant factor. F of n equals O of g of n means that there exists some constant c such that f of n is always less than or equal cg of n function for large enough n. Omega notation for a given function g of n, we denote by omega g of n function the set of functions omega g of n defined by f of n. There exists a positive constant c and n node such that cg of n is greater than or equal 0 and less than or equal the f of n for all n greater than or equals n node. We use omega notation to give a symbiotic lower bound on functions to within in a constant factors. F of n equals omega of g of n function mean that there exists some constant c such that f of n is always greater than or equal c g of n for all large enough n. Theta notation. What is the theta notation for a given function g of n? We denote by theta g of n, that's the set of functions theta of g of n equals f of n. There exist positive constants c1, two constants in c1 and c2, c2 and the n node such that c1 g of n greater than or equal 0 and less than or equals f of n less than or equals c2 g of n for all n greater than or equals n node. A function f of n belongs to the set of theta g of n if there exist positive constants c1 and c2 such that it can be sandwiched between c1 g of n and c2 g of n or sufficiently large n. F of n equals theta g of n and f of n greater than or equals or lies from C1 g of n and C2 g of n. F of n equals theta of gn means that there exists some constant C1 and C2 such that C1 g of n less than or equals f of n less than or equals C2 g of n for large enough n. F of n lies from C1 g of n and C2 g of n. Three functions, O notation, omega notation, theta notation. The following graphic examples for theta, O, and omega. F of n, the first graph of n equals theta of g of n. F of n lies from C1 g of n and C2 g of n. F of n equals O g of n. F of n, the curve f of n and the curve c of g of n. F of n equals omega g of n equals c g of n and this f of n function. This is a graph examples of theta, O, and omega. Example number 1, show that f of n equals half n squared minus 3n equals theta n squared. We must find C1 and C2 such that C1 times n, C1 n squared less than or equals half n squared minus 3n less than or equals C2 n squared. Dividing both sides by n squared yields C1 less or half minus 3 over n greater than or equals C1 and less than or equals to C2. For n node greater than 7 and half n squared minus 3n equals theta n squared. Theorem. For any two functions f of n and g of n, we have f of n equals theta g of n. If and only if f of n equals O g of n and f of n equals omega g of n. Example number 2, f of n equals 3n squared minus n plus 5 equals theta n squared. Prove that because 3n squared minus 2n plus 5 equals omega n squared, and 3n squared minus 2n plus 5 equals O n squared. 3n squared, example number 3, 3n squared minus 100n plus 6 equals of order O of n squared, since for c equal 3, 3n squared less than 3n squared minus 100n plus 6. 3n squared minus 200n plus 6 equals O of n squared, since for c equal 3, 3n squared less than 3n squared minus 100n plus 6. 3n squared minus 8n plus 6 equals of order or O n cube or cubic n, since for C1 n cube greater than 3n squared minus 100n plus 6 when n greater than 3. 3n squared equal minus 100n plus 6 not equals O of n, since for any constant c, cn less than 3n squared when n greater than c. 3n squared minus 100n plus 6 equals omega n squared, since for C equals to 2n square less than 3n square minus 100n plus 6 when n greater than 100. 3n square minus 100n plus 6 not equals omega n cube, since for C equal 3n square minus 100n plus 6 less than n cube, or cubic n, where when n greater than 3n square minus 800 minus 100n plus 6 equals omega n, since for NC Cn less than 3n square minus 100n plus 6 when n greater than 100. 3n square minus 100n plus 6 equals theta n square, since both O and omega apply. 3n square minus 100n plus 6 not equals theta n cube, since only O applies. 3n square minus 100n plus 6 not equals omega n, since only omega applies. Standard notations and common functions, floors and ceilings. X minus 1 less than of the class x less than or equals x less than the class x less than upper and lower less than x plus 1. What is the logarithms? Logarithm, the standard notations and common function for logarithms: log n or log or ln. Log n equals log with the base 2n. Ln n equals the log n for the base e. Log k of the power 2k n equals the log n of the power 2k. Log n equals logarithm. For all reals a greater than 0, b, c greater than 0, and n, a equals b of the power 2 log a with the base b. Log ab with the base c equals log a with the base c plus log b with the base c. Log a of the power 2n with the base b equals n log a with the base b. Log a with the base b equals log a with the base c over log b with the base c. Log b of 1 over a equals minus log a with the base b. A of the power 2 log b of c equal log c for the base b equals c of the log a with the base b. Log a with the base b equals 1 over log b with the base. Factorials: for n greater than or equal 0, then the Sterling approximations factorial n equals root 2 pi n times n over e of the power 2n times 1 plus theta of 1 over n. Factorial n equals O of n of the power 2n. Factorial n equals omega of the function 2 of the power 2n. Log factorial n equals theta n log n.